10 million lashes, but I no cry. 10 years burial, but I no die. Take what's rightfully mine. Take what's rightfully mine. But that aside, you don't know me, you for Google. I say this head bigger than your dugu. Stubborn academy, we like to shoot too. One bullet, I say chale, it go make you poop.
Welcome to my Sword Academy. So today we are going to be looking at a capacitor in circuit or different capacitors in circuit, and we want to analyze to get the charge in each of these capacitor and also the potential difference in each of these capacitor. So now when we watch this question, we are going to see the arrangement of capacitors C1, C2 and C3, that they are arranged in series. So when capacitors are arranged in series, what is the theory involved? We have that the same charge is going to pass through the capacitors because they are in series. So that means the charge that we are going to calculate is the same charge that will flow through each of the capacitors because they are arranged in series. So now we have that the charge is equal to CV. So that means the total equivalent charge will also correspond to the equivalent capacitance. So how do we get the equivalent capacitance? Because you can see we have a potential difference at 16 volts from the diagram, and also we want to see that the capacitors are also in series. We want to calculate for the capacitance of the capacitor when they are in series. We have that 1 all over the capacitance of the capacitor is equal to 1 over C1 plus 1 over C2 plus 1 over C3. So with this, we can make the substitution. So this is 1 all over C1. C1 here is 3 plus 1 all over C2. We have 12 microfarad plus 1 all over C3. We have 4 microfarad. So if we should solve this, we are going to be having that the equivalent will be, so we can multiply or look for the LCM. So you can see clearly that 12 can go here. So 12 is the LCM. So if we should use 12 to divide with 3, we'll be having 4 plus 12 into 12 is 1. Multiply with this, we have 1. Then 12 into 4 is 3. Multiplied by this, we have 3. So this is 1 all over the equivalent. So 1 all over the equivalent is equal to 1 plus 4 is 5 plus 5 plus 3 is 8. So we are having 8 over 12. So, but what we are looking for is the equivalent capacitance, not the inverse of the equivalent capacitance. So that means I have to take the reciprocal. This will come up, this will come down. So we have the equivalent is equal to 12 will come up. We have 12 over 8. So if you should point this in your calculator, the equivalent of the capacitor will be giving you 1.5. Now remember, we did not convert our microfarad, the micro, so we did not convert it. So we leave the answer in microfarad. So this gives us the capacitance of the capacitor equivalent. Now, what we are looking for is the charge equivalent. So the charge equivalent will be equal to C, the equivalent of the capacitance, which is 1.5. So I will convert the micro now to 10 raised to the power minus 6 since we are using it for calculation. Then the potential difference is given as 16 volts. So we have 16. So if you should multiply, you are going to get 24 times 10 raised to the power minus 6 coulomb. So this gives us the equivalent charge. Now this charge which we have calculated is the charge in capacitor C1. So the charge in capacitor C1 is 24 times 10 raised to the power minus 6. In capacitor C2 is the same value. The charge in capacitor C3 is also the same value because they are in series. So the same charge flows through them. Now, meanwhile, the potential difference, we are going to have different potential difference in each of the capacitor. The theory involved doesn't show us that the potential difference will be the same. So their potential difference will be different. That means we'll be calculating for their potential difference. Now, we want to calculate, I will make V the subject formula. Now this time around what we're having is Q equal to CV. So where our V becomes equal to Q over C. And divided by C, I'll be having this. So that means the potential difference in capacitor 1 is this. The potential difference in capacitor 2 is given as this. The potential difference in capacitor 3 is given as this. So if we talk about capacitor 1 potential difference, so this capacitance should be for 1 and this should be for 2. This should also correspond to what? To 3. So now we have the total charge, which is the same charge you have here, you also have here, since they are all in series. So that means we substitute, the charge we got is 24 times 10 raised to the power minus 6 divided by C1, which is 3 times 10 raised to the power minus 6. So if we should divide, 10 raised to the power minus 6 will cancel out 10 raised to the power minus 6. Then 24 will go into 3, we'll be having 8. So that means our potential difference in capacitor 1 is equal to what? 8 volts. So the same way we substitute, we have 24 times 10 raised to the power minus 6. Then C2 is 12 times 10 raised to the power minus 6. So 10 raised to the power minus 6 cancel out. 12 into 24 will give us 2. So we have V2 is 2 volts. Now the same way we solve for V3, we have the charge there is 24 times 10 raised to the power minus 6. Then C3 is 4 times 10 raised to the power minus 6. So 10 raised to the power minus 6 cancel out 10 raised to the power minus 6. Then 24 into 4 will give us 6. So we have V3 is equal to what? 6 volts. So you see that V1 is 8 volts, V2 is 2 volts, and V3 is what? Is 6 volts. Now, the total potential difference can also be calculated, which is V1 plus V2 plus V3. So if you should solve this, you'll be having 8 plus 2 plus 6. 8 plus 2 is 10, 10 plus 2 is equal to what? 16 volts, which gives us the same total volts that we have in the circuit. So that is how we solve that. So the potential difference in capacitor 1 is this. Capacitor 2 potential difference is 2 volts. Capacitor 3 potential difference is 6 volts. So that is how we solve questions when they are in series. Now we are going to see in the next video when the capacitors are arranged in parallel to each other. So we are going to see how we can calculate it and the theory that is also involved. So if you are new to the channel, do well to subscribe and also click the notification bell to get updates of series of videos we'll be posting on physics, chemistry and maths. Thank you.